So, firstly I'm going to talk a bit about how services are produced, what they depend on, talk about some of our work on mapping services, then I'm going to talk about some of more social science work, thinking about how people relate to places and how that impacts on especially cultural services. And then I'm going to come around again and talk about what we can do with this kind of information. How can we use it and make use of what we understand about how the world works. So firstly, one of the easiest services to look at is productivity, because we use it and it's easy to measure. And that means it's been a focus of a lot of research over the years. And a lot of people looked at how diversity contributes to productivity, but we've tried to do it in a slightly different way. So we've been running mixture experiments and looking at productivity in agricultural systems. So we've been looking at how you can alter the number of varieties of barley, and how that impacts on what the weed species do and how they interact. And we've also looked at how these systems, how invasive these systems are by other plant species, other weeds. And this is what it looked like before harvest. So lots of things growing away happily in the greenhouse. Some of them growing very happily. And just to show you one result from this, these are the yield data. So single varieties of barley at that end, single species of weeds, and then the mixtures. The dotted line is the average yield of the monocultures. And you can see it's a lot lower down than the average yield of the mixtures, which is the solid line. Some things to note about this. Overall, the plots with the most diversity were more productive, which is kind of what people confirmed before. But what we found is increasing species diversity had a stronger effect than increasing the genetic diversity present. So that means that it's very much the differences between the weeds are more important than the differences between varieties as well. Changing species richness effectively increased yield through the greater probability of having a more productive species. In this case, if the mixture has Stellaria media in it, particularly, then it's going to be more productive. That was pretty much a given. However, increasing the genetic diversity of the barley did something different. It increased yield, but that's because of better resource exploitation. So that was genuine over-yielding above expectation. So there's complementarity between different genotypes in what they do in the system. They're exploiting resources in different ways. And then, as you increase the weed species richness, it became more and more unlikely that any seeds sown in managed to establish. And this work is going to continue into the new program, and Rob might mention it later. But this is us yesterday, outside Dundee, starting off the new program a couple of days early. But it had to be done because the bulb has just been sown, so we're sowing into quite a big experiment that's duplicating the kind of approach. So, species diversity, but another issue is actually species diversity is quite a crude measure of what's going on in the system. Actually, functional diversity might be a better measure. Excuse the graphics on this is because I can't draw and I have to steal these off the web. Intuitively, the top line, you can see the community on the left is more diverse than the community on the right. That's more biologically diverse. But if you look at the bottom, but you could say they're all pretty much the same. They're all doing pretty much the same. They're all flowers with simple leaves. If we look at the bottom line, the community on the left has much more in the way of functional diversity. Perhaps not so easy to tell the graphics, but these are all pretty similar. We've got quite a lot of different growth forms over there on the left. Or graphically, you think of it like this. On the left, a high diversity system, a lot of range in the traits present, whereas on the right, not so much of a range of the traits present. So the community on the left would be highly functionally diverse community on the right, pretty low functional diversity. And what we're trying to do for this is try and understand if there's a link between that functional diversity and productivity again. So buried in my office is some data from previous experiments that actually were run by the Hill Farming Research Organisation, which is a predecessor of Macaulay, which is a predecessor of James Hutton, and a few from the Macaulay days as well. And what I've done is extracted that and looked at whether productivity could be related to functional diversity in these communities. And to do this, you can expect that productivity is dependent on the environment and dependent on the traits of the species. So you kind of have to fit those first into any model. So you know the warmer the site is, the more it's likely to grow, that kind of thing. And a whole range of traits, not too important in detail. And interestingly, the best fit was with this trait called leaf dry matter content, which is perhaps the simplest trait, or perhaps the second simplest trait to measure. The first is probably height, but it's just the difference, the ratio of the dry matter of the leaf compared to its fresh mass. So the simplest trait you can imagine. But that explained about 60% of the variance in productivity on its own. And then once you added rainfall, that explained a bit more as well. But adding, with leaf dry matter content in the model, as soon as that was in, functional diversity didn't make any difference. So we can't really say in this system that a more functionally diverse community is improving productivity. However, eyeballing the data suggested some of these sites with less functional diversity have more variable productivity. So it's doesn't explain a huge amount of the data, but the more functionally diverse systems have less variability in their productivity, which suggests that higher functional diversity might be providing more resilience within the system, more dependability in productivity. So if you perhaps want to manage for this dependability, you might increase diversity in the system. Shifting to the second area I want to talk about, mapping of ecosystem services. It's not really an option, we've got to do this. UU biodiversity strategy says this, and the land use strategy itself calls for decisions that are based on maintaining the benefits. And if you don't know what you've got, you can't really maintain those benefits. So we've done quite a lot of this. One of the simplest ones, again, productivity. But this is done from satellite data. And as you can see, two comforting things show up. All the high mountains seem to have low productivity, and also Edinburgh and Glasgow seem to have good productivity. So it's nice and comforting. But you can see below you ground tends to have higher values of productivity, better climate basically. We've also done some modelling of pollination services. So this is habitat suitability for a range of bumblebee species present in Scotland. Again, you can see spatial patterns developed there. So flow country and the top of Lewis, pretty bad habitat suitability for most of these bumblebees, and better shorter ground. But we can take that kind of information and look at the service these pollinators can supply to crops. As you can see, the brown and warmer colours are where it's higher, and that kind of outlines the upland fringe, but the best agricultural ground kind of picked out in blue, suggesting there isn't a good supply of pollination from which the crops we grow, which is alright since most of what we grow is barley, but if you're thinking beans and things like that, and to a certain extent oilseed rape, there's not a great deal of supply of pollinators to those crops. We've also taken a different approach to modelling the amount of carbon present in soils. As you might expect, low ground, pretty low values, and increasing values as you get up to more peat-rich areas. Nothing too surprising, but it's completely independent from previous maps of soil carbon which have been developed based on soil surveys and sampling. So it gives a nice check and a nice way of seeing if those kind of point-based data can be extrapolated confidently. And we can also start to look at cultural services. It's a bit blocky because the nature of the data comes in 10 kilometre squares, where you can see certain areas we should value higher for plant biodiversity in this case than others because of their distinctiveness. So, for instance, the top of the Cairngorms, some of the higher places like Ben Law's picked out more than the plains of Buchan or the grasslands down by Edge. So, to summarise that, we've produced quite a lot of information, but then there's only 11 maps there and quite a few of them are to do with our production. So we've got a long way to go still, but we have made a start in producing these kind of maps. And you can start to think about using these for looking at where areas have pretty high multifunctionality or low multifunctionality. And then beyond that, we can even think about how you could target incentives to these areas of high multiple benefits, or to target incentives to create those areas of high multiple benefits. Which begs the question, can we also map other cultural services and contribute to those much more physical-based services that I've shown you earlier? One of my colleagues has been looking at this and taken 5 possible indicators of cultural value, and all this is sort of available data. And you get a map like this if you put those 5 together. So again, picks out some of the high ground quite easily, but interestingly, it's a very, I think what the word is, there's no large blocks particularly in there. There's a lot of fine scale detail depending on what you pick, but it does pick out some interesting features as well. So it's possible, but it really depends on the spatial availability, the availability of spatial data. So a lot of these sort of indicators for cultural services, they're based on quite unusual data sets, quite things you perhaps wouldn't select if you're starting from scratch. And the things that we found are really difficult are sort of spiritual and symbolic aspects of cultural system services, because those are much more individual than perhaps some of the other ones about areas of high conservation value. So, like I said, mapping cultural services will prove difficult because different people have different ideas about what they value. So some of my colleagues did some work looking at how perceptions of different groups of people of peatlands could influence how the National Peatland Plan was implemented. And the National Peatland Plan is there because Scottish peatlands are often less than pristine, a bit of erosion going on here, not bare peat, and this is the ideal. It's a bit dark, it's a really nice picture on the screen, but I'm sorry it's a bit dark up now. So we have workshops in Aberdeen and over on Lewis. As you might expect, Aberdeen, people there were mostly urbanites or people living in the area around about. Whilst Lewis, these are rural citizens, and they've grown up and live in areas where there's a lot of people. Two quite contrasting groups. The participants were mixed up from a wide range of backgrounds as far as possible, but of course there's a difference between the two sites in terms of the experience with peatlands. And some of the questions they asked in these workshops were, where should we restore these peatlands? And quite a range of answers came out. We should be doing it in, well, these are the two extremes. One extreme, we should do it in remote and wild areas. So there's a chance of these being the restored areas being undisturbed in the future. But other people said, well, we should be doing it close to cities, because that's where people will experience it more and learn to value them more, which is an interesting dichotomy. And then something that actually taxes conservationists everywhere is, where do you do it? Do you put all your action in preserving the best of stuff, or do you put all your action into trying to improve the little bits around the edge of the distribution, because they're actually quite rare around the edge of the distribution? So should we put our effort into restoring the flow country, or into restoring raised hogs in the central belt or in Appalachia? That's the real dichotomy there. And as you might expect, the perceptions between the two groups were somewhat different. So as you might expect, the people of Lewis see peatlands as a system they can use. So they're for sheep grazing, of course, and also using it for peat and for fuel. And this is part of their cultural identity. Going on the hill, cutting peat, letting it dry, and then collecting it again at the end of the summer. Whereas the people interviewed in Aberdeen in the workshop were much more conservation oriented. They thought these peatlands had a value in being maintained for their biodiversity and, of course, for their carbon storage. So it brings into view that actually we might see peatlands differently, whichever scale you're looking at. So at a national scale, people might think about these peatlands as wilderness areas, because there are very few people there, and they'd be valued for their biodiversity and for their difference from their normal experience. Whereas at a local scale, these peatlands can be seen, they're just part of the cultural landscape, and they're valued as part of a working environment. On to the final topic area I want to cover, just some of the work from the land use pilot. This had two main strands: research with stakeholders in the local focus areas, and then sort of modelling to look at the impacts of land use change. So one of the focus areas was Upper Deeside, and you can see there's a deed running along there. Actually, if you come to the front, you can see that's where the deed's running. Not a great deal of population up there, and it's divided into a small number of large estates, not too much in the way of farms. And this contrasted with the Devon catchment, with Huntley as its main town, which is much more farming-based. The estates much lower presence there, and a bit more higher density population, but still, in terms of most of Scotland, pretty rural. What was interesting about this study is that the participants picked up on the idea of services very quickly. In fact, they were very good at identifying the benefits that people derive from ecosystems, and so they extended it beyond our normal classifications. And they understood where conflicts might occur. So the sort of regional policy questions we're asking are very much already identified on the ground. So people are very aware of potential conflicts in that area. And again, a strong idea of who are the main players in the system, who's going to influence change within that system. And again, people who might be able to influence change may be the ones who only get some of the benefits from that system. They may be the ones getting financial benefits, but not the other sort of service benefits. And then some interesting views on the moral component of managing land. What's land for? And ideas about stewardship rather than about exploitation. Well, the clear message that came out from all the workshops was the benefits to rural society and economy do matter. And they are intrinsically linked to the services that we derive from land, in terms of both the sense of place, local employment, and local industry. But unfortunately, they did show, well, it's interesting but unfortunate is that catchments are complex systems. And even this simplified schematic model of how land is run and managed and provides benefit is too hard to model in the real world. So our understanding that was developed during the workshops would be really difficult to try and put together into something as a functional model. And even this fairly simple model, one of the things it really misses is the sort of feedback loops between decision makers and the drivers. On that note, then I will spend the next couple of slides talking about the mapping tool we've developed, which tries to do what I've just said on the last slide would be very difficult to do. It is available, it's interactive, it's web-based, and it can be used to look at some of the consequences of different land use change on existing service delivery. I say some. It's a basis for development, but it has some interesting properties. So this is just a screenshot of what you can do. It's a very simple model. You just play with the sliders, and you can change how the land looks in terms of its suitability for woodland expansion. So green is sensible areas to put in woodland, the red are less sensible areas to put in woodland. And part of that is unsuitability of the site in terms of woodland tree growth, and part of it is you perhaps will want to put it on high value agricultural land or on land that had a conservation designation or something like that. And one of the things you can do is play around and look at the consequences of woodland expansion on various services. And this, for instance, is a map showing at a sub-catchment level the impact of woodland planting, where you would put the most sensible areas for 4,500 hectares, what that impact would be on carbon sequestration. So the tool isn't a way of saying this will happen, but it's a way of saying what if. So it's a way about thinking about change. And what it does is it takes an awful lot of data and tries to put it into as simple a package as possible. There's a lot of complicated calculations underlying it, but the users don't need to know that. They need to have an idea of what their different decisions are doing to the landscape. But it's a basis on which you could develop a strategic approach and think about how to deliver multiple benefits from different decisions. So if you are planting woodland, where would be the best choices in terms of, say, recreation provision as well as in terms of just amount of wood due to timber produce. But there's still a problem with data. Some of the data is very high resolution. Other data, like things like species distribution, is still limited by the 10-kilometre scale very much. And I think what the combination of the land use, the tool, the mapping tool, and the workshop showed is that local knowledge about what's practical in the system is still vital. You can't sit in an office and play with the model, play with the sliders and come up with a decision. It's engagement with the people who know, even down to the level of the landowner, what's possible, what's not possible in the system. And the interesting thing, I think the most interesting thing that I've learned from this process is, the model is very much based around land use change, but there's so much that can be done by changing land management. People on the ground think more about changing land management than about land use change. So farming system, they'll be thinking about changing how often they reseed or what they plant or the grazing levels. They won't be thinking so much about putting forestry, something like that. So I've been talking long enough. So this, I stress, is a very small selection of what we've been up to. For instance, I've not talked about Maria's forestry work at all. I've not talked about the valuation stuff we've been doing. I've not talked about the service, the croplands service work we've been doing, looking at how farming in the lowlands produces services. and quite a lot else. So this has been a very, very short selection. But I think over the last 5 years, we've done some work that's contributed to science and to policy. And hopefully it's going to be a firm basis for developing the next programme, which starts on Friday. So thank you for listening, and I'd just like to thank my many colleagues who are too numerous to put onto a slide, and more especially the many stakeholders who've contributed to this research and engaged with it